Yes, folks, welcome to our fifth lesson on Matrix Form 3. Today, we are going to concentrate on one of the application of inverse. The previous lesson, lesson 4, dealt on what was inverse and how to get an inverse of a 2 by 2 matrix. Now today, where do we use that skill? Where do you use that application? When you have an inverse, where does it help you? I have an example here that you can be asked to solve a pair of simultaneous equations using matrix method. You know, we can just solve this the usual way. You create a constant and then you eliminate it. But now you will be told using matrix method. Now, key thing, whatever you are given has to be in a particular mode. So, if your variables start with x, then the first equation and the second equation must always start in x. If it is followed by y, the same thing to the second equation. So do not mix the system of variables. I've started with x followed by y. So even the second equation must be x followed by y. That is one trick you can get in exam. They can mix for you the variables. X, y in equation 1, and then equation 2 they say y, x. No. Get it clear. So you can see the system I'm talking about. X, then y, and then constant. Having done that, fortunately for us, this was in the right mode. Number 1, extract the matrices. That is, we shall extract 3 matrices from the 2 equations. Number 1, coefficient matrix. I've just written it in short. It is called coefficient matrix. What are the coefficients of the variables? The variables I have are x and y. So what are their coefficients? They form a matrix. Now you can see 2, 5, 2, 5, and then 3, 4, 3, 4. That data in a bracket forms a matrix. Another thing is we have x, y. You write them in a column form. So this is 2 by 2 and this is 2 by 1. Compatible. They can be multiplied. And then this is called constant matrix. The constants are written in their own matrix. So do you remember now here? Extract matrices. How many? 3. One is called coefficient matrix. The coefficient matrix can only be extracted if the variable x, y are in harmony. They have been written systematically. This question I can also reverse. I begin with 5y plus 2x is equal to 9. I can also reverse the second one. 4y plus 3x is equal to 6. So what would be the coefficient matrix here? You see, we are talking of 5, 2, and then 4, and then 3. And then I would have x, y is equal to 9, 6. Y, x. That would be correct, my friend. It would be correct. You can see I've reversed the order of variables. It is y, x. Look at the variable matrix. It is now y up, x down. Okay? You cannot reverse and maintain the original matrix. So this is workable. Okay? So I don't want to rub it. I can say or this. So that point is clear. Number one, extract the three matrices from the two simultaneous equations. What are we doing? We are trying to apply the application of inverse. Tumepata inverse. Huwa inatumika wapi? Where is it being used? Okay? So this is procedural. Number one, extract three matrices: coefficient, variable, constant. They are here. Okay? Maybe I can just add that and variable matrices. There. So they are here. Okay? So you will do the same question using this. Now that is followed by get inverse of coefficient matrix. The coefficient matrix that you have, you can say let it be A. So letter A, capital A, represent this. Then do you remember how do we get the inverse? 1 over 2 by 4 is 8, leading. Okay, you can put your additional word in your mind to help you. I said this is / diagonal minus / diagonal, or leading diagonal minus rear diagonal. So I have 8 minus 15 giving me minus 7. Okay, that is -7. Then you put your bracket. The leading elements swap. 4 goes up, 2 goes down. This rear diagonal, you write the opposite. I have positive. The opposite of positive is negative, but they retain their positions there. So you have here, boys and girls, you have here. I want you to get this procedure right. Procedure number 3 will be pre-multiplication. So we will focus a bit now. Okay, again I bring it forward a bit, the camera. Yeah. So pre-multiplication by inverse. We have already the inverse. So what do? You pre-multiply both sides of the equation by inverse. Pre-multiply both sides of equation 1 by inverse. So I add here by inverse. Okay, there. Correct. Pre-multiply both sides of equation by inverse. So look at my blue is the inverse I got. See what I mean by pre-multiplication. It starts. We have an equation. An equation has left-hand side and right-hand side. So you start by inverse. Here, look at blue, so that you understand the pre-multiplication. My friend, here you score 1. We have 1. You can have all this. You have that. Okay? You have that. So sometimes this may not score because it will be very ordinary. But this one, you have a mark. You have a mark. Now remember what we learned. This blue times this black. This is A inverse. This is times A. Will always give you identity. So this is identity matrix. That gives you identity matrix. Identity matrix here. Again, I want to focus a bit so that we get things right. Let it be focused now on the lower part. We are doing number 3. Pre-multiply by inverse. Inverse comes before you write anything on both sides. Remember, this gives you this. This is the same. This. Negative 1 over 7 is here. So why have I not brought in the scalar? I want to handle this first. So what do? You handle only this and that. Can we see? 4 by 9, 36. Okay? And then we add. So we add. Maybe people will confuse here. So I do for you plus. This is negative 5 times 6, negative 30. This. Then I have finished with the column because it is only one. Now I am allowed to go to the R2, second row. Again I do negative tail and tail. Negative 3 times 9 is negative 27. 2 by 6 is 12. So compute this. If I compute this, this gives me 6 positive. But this gives me negative 15. Okay? Now, I can make an adjustment here. I want this way. X, Y. I want to explain. Any identity matrix times another matrix. Any identity matrix times another matrix. Identity matrix times another matrix is that matrix. It's like multiplication in algebra by 1. If I say 1 times 10, the answer will remain 10. 1 times 5, the answer remains 5. So an identity matrix is equivalent to 1 in algebra. 1 does not change the value of the other factor. So this times that gives you this, and then you come and say is equal to, now I can bring in the scalar. So negative 6 over 7 and then 15 over 7. Okay? Which implies x is equal to negative 6 over 7 and y is equal to 2 and 1 over 7. So we have that, we have this. Look at that. Okay. So you have, this is the core of the lesson. We have found the value of x and y using matrix method to solve simultaneous equation. There are very many uses. There are very many uses of this, but for now, I think we can have it that. So in conclusion, if you are told to solve simultaneous equation using matrix method, number 1, before you do anything, check that the variables have been harmonized. Equation 1 variables and equation 2 variables. If this equation 1 begins with x and then y and then constant, then you do the same to equation 2, x, then y, and then constant. Okay, that is checkup. Then you come to number 1. Okay, extract 3 matrices: coefficient matrix, variable matrix, and constant matrix. Number 2, you must have somewhere to write. Number 2, what do? You let A equal to coefficient matrix and get its inverse. That work is acknowledged by 1 mark. Number 3, pre-multiply both sides of equation 1 by inverse. You score there. Then go now systematically multiplying the corresponding row and column, and then leave out the scalar. Bring in the scalar in your last step and get the value of x and y. Subscribe for more. Till then, bye-bye.